My Weekend with Trapezoids and Kites by Jordan Green.
I did my geometry project over lesson 8.5, which covers the property of kites and trapezoids. This chapter was kind of confusing to me because there are so many properties that trapezoids and kites have. It was just hard to remember all of them. But in this video, we'll be going over them again so you can understand them more, and we'll be practicing different problems.
Saturday with Trapezoids.
Ready? Come on, Lucy! As I was walking my neighbor's dog, Lucy, come here, Lucy. We came across a rock that looks like a trapezoid.
This is a trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides, called bases. These bases are always opposite of one another. The other non-parallel sides that make up the trapezoid are called legs. Just like the bases, the legs of a trapezoid are always opposite of one another. We now know the properties of a trapezoid, but how can we prove that this rock is, in fact, a trapezoid? Well, we can do this by comparing the slopes of the opposite sides of the trapezoid. Remember, if the figure is indeed a trapezoid, it will have exactly one pair of parallel opposite sides, as well as exactly one pair of non-parallel opposite sides. After putting the trapezoid on a coordinate plane, we will start to find the slope of one pair of opposite sides. Starting with the top side of the figure, I found that its slope was 4/6, which simplifies to 2/3. Next, I calculated the slope of the opposite side and found that it was 6/9, which, when simplified, is 2/3. Now that we know that both of the slopes are congruent, we can conclude that the sides are parallel. Now to start on the other pair of opposite sides. I started on the left side of the figure and calculated that the slope is -7/1, which simplifies to just -7. After that, I went to the opposite side, or the right side of the figure, and found that its slope is -5/4, which cannot be simplified. -7 does not equal -5/4, meaning that the slopes are not congruent. If the slopes are not congruent, the sides are not parallel. Now that we know the figure has exactly one pair of parallel and one pair of non-parallel sides, we can classify it as a trapezoid. I hope you had fun learning about the properties of a trapezoid and how to show that a figure is a trapezoid. I know Lucy and I did.
On my way home from golf practice, my mom and I stopped at a gas station. And while we were there, we spotted a trapezoid on one of the bins.
Let's say we wanted to find the length of the midsegment of our trash can trapezoid. The midsegment of a trapezoid is a line segment that connects the midpoints of the legs. The midsegment and both bases are always parallel, and both legs of the trapezoid are always split into two congruent segments. The top base of our trash can trapezoid, which I renamed trapezoid ABDC, is 7 units, and the bottom base is 12 units. To find the midsegment of our trapezoid, we must use the midsegment theorem. This theorem states that the midsegment of a trapezoid is equal to 1/2 of the sum of the lengths of both bases. In other words, the midsegment length is the average of the bases. So now that we understand the midsegment theorem, we can solve the problem. Calling midsegment EFX in our equation, we start off with plugging in our numbers and get x equals 1/2 of 7 plus 12. Now we add the numbers in the parentheses, 7 and 12, and we get 19. In our final step, we multiply 19 by 1/2 and find that the midsegment is 9.5 units.
My family and I went to Buffalo Wild Wings for dinner, where we found some chips that were shaped like an isosceles trapezoid and a kite.
An isosceles trapezoid is a trapezoid whose legs are congruent. You can tell if a trapezoid is isosceles if each pair of base angles is congruent, the trapezoid has one pair of congruent base angles, or if the trapezoid's diagonals are congruent. Sunday with kites.
Look, we found a kite in the sanctuary.
This is a kite. A kite is a quadrilateral that has two pairs of congruent consecutive sides. However, the sides opposite of one another are not congruent. You will know if the quadrilateral is a kite if its diagonals are perpendicular. If the quadrilateral is indeed a kite, its smaller diagonal will be bisected by the larger diagonal. Or if the figure has exactly one pair of congruent opposite angles. These angles are always going to be adjacent to your two smaller sides. Let's say that we want to find angle B and angle C in kite ABCD. I'm first going to solve for angle B, even though there's not much solving to be done. Remember that the two angles adjacent to the small sides and opposite of one another are congruent. That being said, angle D is congruent to angle B, which means that angle B equals 65 degrees. Now, we're going to solve for angle C. All of the angles of a quadrilateral always add up to 360 degrees. That means that the sum of angle D, angle A, angle B, and angle C equals 360. Once we plug in our numbers, we can add them up. Our equation is now 208 degrees plus angle C equals 360 degrees. Subtracting 208 from both sides, we find that the measure of angle C is 152 degrees.
After church, my family and I went to Brookhaven Country Club. While we were eating, I found a kite on the pavilion.
I want to know how long the side lengths are of the pavilion kite. The kite is split up into 4 right triangles, and the diagonals serve as their legs, with lengths of 4, 6, and 12. We are going to first find our short side lengths. In order to do this, we will use the Pythagorean theorem. Our equation is going to start off with 6 squared plus 4 squared equals the side length of AB squared. Simplifying that, we get 36 plus 16 equals 52. Now we need to find the square root of 52, and we get approximately 7.2 units. Since AB is congruent to AD, AD is also 7.2 units. Now, we are going to find the lengths of BC and DC. We plug in our numbers into the equation and get 12 squared plus 6 squared equals the side length of BC squared. Simplified, 144 plus 36 equals BC squared. Now, we have to find the square root of 180, which is approximately 13.4. BC is also congruent to DC, which means that DC is also 13.4 units. We have now finished our equation. We calculated that AD and AB equals 7.2 units. Also, we found that DC and BC equal 13.4 units. And that concludes our weekend with trapezoids and kites. I hope it was helpful.